You ever stop and think about what gives your favorite food that perfect feel? I mean, it's not just about the taste, right? Every single thing we eat has this kind of hidden personality that's all about how it feels in your mouth. So let's go uncover the science behind that, this amazing world of food texture.
Okay, think about this. What makes a bagel perfectly chewy? I mean, what is that satisfying resistance when you bite into it? It's that springiness. It's so hard to put into words, but you know it the second you feel it, right?
Or, let's flip it around. What about a yogurt that's just perfectly smooth and stable? You know, the kind that holds its shape on the spoon? It's creamy but not runny. It's not rubbery either. Believe me, these textures are not an accident. They are engineered down to the last detail. So, what's the secret sauce?
Well, the answer is actually pretty simple, and it's hidden in how they react to stress. Yeah, you heard me. It's all about how these foods respond when you put a little bit of pressure on them. That reaction, that is what defines their whole personality.
And that brings us to the hero of our story today. It's a scientific property with a pretty big name, but trust me, the idea behind it is super simple. It's called viscoelasticity. And this one concept, it's the key to unlocking the texture of pretty much everything we eat. So what on earth is that? Well, the name kind of gives it away, right? Visco and elasticity. It's a mashup of viscous, which is just a fancy way of saying liquid-like, something that flows, and elastic, which is all about that solid-like bounce. The thing is, foods aren't just one or the other. Nope, they're a really complex mix of both.
Okay, so think of it like this. You've got these two competing forces. On one hand, you have the elastic or solid-like stuff. Think of a rubber ball. It stores energy and bounces right back. On the other hand, you have the viscous or liquid-like stuff. Think honey. It just flows. It loses that energy. Viscoelastic foods, they're doing a little bit of both, all at the same time.
All right, so how do scientists actually measure this stuff? I mean, how do you give a food a personality test? Well, they run this super precise experiment to see exactly how a food deals with being put in a, let's call it a stressful situation.
It's basically a squish test. No, really. A machine takes a little sample of food, it squishes it down by a tiny, precise amount, say 1 millimeter, and then it just holds it there, perfectly still, for a whole 60 seconds. And the entire time, a sensor is measuring just how hard that food is pushing back.
Now, the key here, the really important part, is that the amount of squish, what scientists call strain, is held totally constant. They don't push any harder or let up at all. They just watch how the food's internal pushback force, the stress, fades away over time. And that, my friends, is called stress relaxation. Okay, now for the really cool part, decoding the data. Because the numbers that come out of this 60-second test, they give us a totally unique fingerprint for each food. It's how we reveal its true personality.
So what we get is this graph, and it's called a relaxation curve. It shows you the maximum force right at the beginning, the instant the squish happens, and then it tracks how that force just kind of decays over the next 60 seconds. And you can bet that a chewy bagel is going to have a totally different looking curve than a creamy yogurt.
Now, the easiest way to make sense of this curve is to boil it all down to one single number, the percent stress relaxation. It's really just a simple percentage. It tells you how much of that initial pushback force the food lost over that 1 minute. Think of it like a quick snapshot of its behavior.
And this really shows you what that number means. If you get a low percentage, it means the food is more elastic, more solid-like. It kept most of its pushback force. It was fighting back. But a high percentage? That means it's more viscous, more liquid-like. It lost most of its force. It basically gave up and started to flow. But that one number is just the headline, you know? It doesn't tell you the whole story. To really get the nuances, like the difference between its initial springiness and its long-term flow, we need a more powerful tool. We've got to dig a little deeper. And for that, scientists turn to a really powerful tool called the Maxwell Wiechert model. This is what lets them go way beyond just a single score. It helps them decode that curve's true meaning and map out the food's entire personality profile. So what this model does is it basically breaks down the food's inner workings. It can see the elastic memory. That's the solid backbone, the part that never fully gives up. Then it can separate out the fast relaxation. That's the initial quick, springy response. And it can also see the slow relaxation. That's the long-term, viscous flow, like a slow ooze. It gives us the whole picture.
Okay, I know this might all sound super technical, but why does it matter? Well, it has a huge impact on the food you find in your lunchbox every single day. This is where the lab meets your life. I mean, food engineers use this science to perfect everything. For baked goods, they're looking at the gluten network to get that ideal chewiness. For dairy, it's about the firmness of cheese or making sure your yogurt isn't a soupy mess. For meats, it's all about tenderness. Even for things like gels and spreads, it's about getting that perfect mouthfeel and spreadability. It's all connected back to this one idea.
So here's my challenge to you. The next time you eat anything, really pay attention. What will you notice about its secret personality? Is it more of a rubber ball or more like honey? Does it have that quick, springy pushback or more of a slow, gradual ooze? Now you know the science behind it all.